Hi viewers, you are welcome back to class. This session I'll be teaching sequences and the subtopic under it is sequences and rules. A sequence is an arrangement of two or more numbers in a successful order. Sequence is an enumerated collection of numbers in which repetitions are allowed and order matters. In a sequence, rule that governs it is always important, and the first term is also very important. So if you have the rule that governs a sequence and the starting point, you can always create a sequence. The numbers in the sequence are called terms. The numbers you have in a particular sequence, they are the number of terms in that sequence. The starting point of a sequence is called the first term, and the rule that governs a sequence is often referred to as the term to term rule or next term rule. The terms in the sequence are all generated by the same rule. The first term, the second term, the third term, up to the nth term of a particular sequence, they are all generated by the same rule. And the sequence can be continued forever. In other words, the sequence can have infinite number of terms. When the number of terms of a sequence is an unending number, it is called an infinite sequence. But when the number of terms of a sequence is limited, if you have a specific number of terms, a countable one, for a sequence, it is called a finite sequence. Fine. So to start with, in sequence now, we need to have the rule that governs the sequence, the starting points. The moment we have that too, we can start up a sequence and a sequence can be generated. Hello, the first example the first sequence to generate, the rule that governs it is add 3. So for the first sequence, the rule is add 3. I'll put the rule in a bars, and the starting point is 1. So with the rule as add 3 and the starting point 1, I can generate my sequence now. The first term of the sequence is 1. The second term will be 1 plus 3, since the rules that governs it says add 3. So the second term will be 1 plus 3. The third term will be 1 plus 3 plus another 3. The fourth term will be 1 plus 3 plus 3 plus another 3. First term, second term, third term, fourth term. Let's do it up till fifth term. And the fifth term will be 1 plus 3 plus 3 plus 3 plus another 3. Now I want us to completely establish the sequence now by writing all the first 5 terms that we are been working on here. So it will be 1, followed by 1 plus 3, which is 4, followed by 1 plus 3 plus 3, which is 7, followed by 1 plus 3 plus 3 plus 3, which is 10, followed by 1 plus 3 plus 3 plus 3 plus 3, which is 13, and so on. So this sequence is a particular sequence with an unending number of terms. The number of terms for this sequence is infinite. There are some other sequences that have specific number of terms, and those ones are sequence with finite number of terms. They are finite sequence. So we've been able to generate a sequence now. The second sequence now. The rule for this second sequence is still add 3. The rule is still add 3, but the starting point, the rule is add 3, but the starting point is 6. Starting point is 6. So viewers, we can generate the second sequence now by writing the first term, which is 6, and it is the starting point, followed by the second term, which will be 6 plus 3, because the rule still remain add 3, followed by the third term, which is 6 plus 3 plus 3, and the fourth term, which is 6 plus a 3 plus a 3 plus another 3, and the fifth term where we will stop for this sequence, which will be 6 plus 3 plus 3 plus 3 plus another 3. So we can try to establish this sequence completely to be the first term of it being 6, second term being 6 plus 3, which is 9, the third term 6 plus 3 plus 3, which is 12, the fourth term, which is 6 plus 3 plus 3 plus 3, which is 15, and the fifth term, which is 15 plus 3, which is 18, and so on. Another easiest method is, since we have the rule, the first term is 6. 6 plus 3 gives 9. So the third term will be adding 3 to the previous term. To get subsequent term, you add 3 to the previous term, since add 3 is the rule. And that is why it is very important. Without the rule, you can generate a sequence. So 6 plus 3 gives 9. 9 plus 3 gives 12. 12 plus 3 gives 15. 15 plus 3 gives 18, and so on. This is also an infinite sequence. We can move to another one, which the rule is double. The rule for this next sequence now, which should be sequence 3, the rule is double. Okay, for the third sequence now, the rule is double, and the first term of the sequence, or the starting point for this sequence, is 1. So viewers, we can generate the sequence now. The first term is 1, and the rule is double. So what we have to do to this first term to get the second term is to double this. How do we double this? We have a 1 plus 1, and it gives us 2. It gives us 2. So for the next term, we're going to get 2 plus 2, which gives 4. For the next term, we're going to get 4 plus 4, which is 8. And for the next term, it will be 8 plus 8, which is 16. And for the next term, it's 16 plus 16, which is 32, and so on. And for this double, it can be done in a multiplicative operation. Like this one now, the double is done in an additive operation. It can be done in a multiplicative operation and we'll still get the same sequence. The first term is 1, fine, and the rule is double, which means I will have 1 multiplied by 2 to get my second term. My second term is 2, so I will have 2 multiplied by 2 to be my third term. 2 multiplied by 2 gives 4. So to get the fourth term, I will have 4 multiplied by 2. To get the fifth term, I will have 4 multiplied by 2 gives 8. I will have 8 multiplied by 2. And to get the sixth term, 8 multiplied by 2 gives 16. I will have 16 multiplied by 2, and so on. It's also a kind of sequence with infinite number of 10. And I've done it in 2 ways now. I've done it using the additive operation, and I've also done it using the multiplicative operation. Now I want to completely establish the sequence. For the first term, which is 1, followed by the second term, which is 1 plus 1, 2, the third term, which is 2 plus 2, 4, the fourth term, which is 4 plus 4, 8, the fifth term, which is 8 plus 8, 16, and the sixth term, which is 16 plus 16, 32, and so on. Looking at it in the multiplicative operation, the first term is 1. 1 by 2 gives 2. 2 by 2 gives 4. 4 by 2 gives 8. 8 by 2 gives 16. 16 by 2 gives 32. Good. We can also establish the fourth sequence with the rule double. We can also establish the fourth sequence with the rule double, and the first term, or the starting point, first term being equals to 5. This one, I'll just pick either of these operations since it will arrive at the same thing. Since we'll be getting the same result, there's no need of repetition. So I want to be happy to pick the multiplicative operation. So if the first term is 5, the second term is 5 by 2, which is 10. The third term is 10 by 2, which is a 20. The fourth term is 20 by 2, which is a 40. The fifth term is 40 by 2, which is a 80. And the sixth term is 80 by 2, which is 160, and so on. And so to completely establish or to completely generate the fourth sequence, we have the first term to be 5, the second term to be 5 by 2, which is 10, and the third term to be 10 by 2, which is 20, and the fourth term to be 20 by 2, which is 40, and the fifth term to be 40 by 2, which is 80, and the sixth term to be 80 by 2, which is 160, and so on. Thank you, viewers, for watching. This is just an introductory class for sequence. In the next class, we'll be going into some example and probably getting some formulas to easily navigate when solving questions on sequences. Thanks for watching. Do like, share and subscribe to my channel. Bye.